Math 125, this is practice test 1, question 9. Supposed to determine if this argument is valid or invalid. So let me write a symbolic argument for it. If I pick you up, I'll call that P. Then, implied then, I will get a hernia, I'll call that Q. If I get a hernia, I've already called that Q, then I can't play we. I could go two ways with this. I could call this R or I could call this not R. I'll just call it R. I can't play we is the statement R. And notice, I can't play we, the next statement, I can play we, is the opposite of that. That would be not R. Therefore, I didn't pick you up. I pick you up was P, so this would be not P. So the structure of this argument would be P implies Q. I pick you up, I get a hernia. Q implies R. If I get a hernia, then I can't play we. Again, you could have done that not R, and that the next one would just be R. I can play we as the next, so the opposite of R. Therefore, not P. So this one has 3 different pieces to it. The argument I'm going to prove is P implies Q, this and this, Q implies R, and not R. So all of these are just connected with an and that must necessitate that not P happens. This implies not P. Okay, P, Q, and R. Let's do it. True, 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 true. False, 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 false. True, true, false, false. True, true, false, false. Last one's just going to alternate my true, false values. All right, so P implies Q. True, true. Again, the only time an implication is false is when a true implies a false, where the if part happens and the then part doesn't. And if the if part is false, it hasn't been disproved, still true. So that's that piece right there. I'm going to build up Q implies R. Q implies R. So true. There's a sloppy false right there. There's a false. True, true. True. The only time it's false is when true implies false. And if the first part's false, it's true. So I have this part, this part. So now I'm going to throw in a not R. That's just the opposite of R. R went true, false, true, false, true, false. So I'm just going to go false, true, all the way down. All right, so there's that part. And so now notice what I have to do is connect these 3 columns up with an and. So this and this and this. So what that means is all 3 of them have to be true for an and. So if I see one false in there, it's false. And look, there's only one true in this, which is this last line. So there's this, I just wrote and, but that's really that whole part. It needs to conclude not P. So let me get a not P in here, opposite of P. Remember it was 4 trues, 4 falses, so flip that, false, 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 true, 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 true. And now, since this represents this part and this represents this part, I want to know, does that imply that? Again, I'm looking for a tautology to see if it's valid or invalid. I'm just going to do it in here because it's easy. And if my initial part of my implication is false, it's true. So all these are true. That's pretty easy. That's looking pretty good. And then true implies true. Yep. That is a valid argument.